Hi guys, so today we are going to be using a different technique to solve a system of linear equations. As you guessed it, we are going to solve the systems by substitution. Fantastic. The one neat thing about solving a system by substitution is that we don't have to rewrite any of the equations in a certain form. We can just get to it. Okay, so again, we are asked to solve the system by substitution. So we are not given the green light to solve this system however we like, so please use this technique. So substitution, how does it go? So the way it works, you're going to pick any equation and solve for any variable. So let me go ahead label these equations because I'm going to start speaking to myself. So we can pick, in this case, any of these two equations and solve for the x variable or solve for the y variable. It's really up to you, okay? Whatever one suits you. Ideally, it would be nice if we had a variable whose coefficient was 1 or positive 1, but that's not the case here. So this is how I do it. I'm going to see if we have what I call a good candidate, which is my made-up words to say, is there a variable that we can solve for that will give us integer coefficients? Okay, I feel like I'm speaking in a different language. Okay, let me break it down. So if I were to look at the first equation and solve for x, what would the numbers look like? If we were to solve for x, we would eventually divide both sides by 4. 4 goes into 24 and into 8, and it's negative 8. 4 goes into 24 and 8 a clean number of times. So it wouldn't be a bad idea to solve for this x. So let me go ahead and circle it. So I'm going to say x in the first equation is a good candidate. We can just do that, solve for x in the first equation, and that's it. But let me look at the remaining three terms. What if I wanted to solve for y in the first equation? Would that be like a good choice? I mean, you could do whatever you want, but the choices you make will determine how brutal this problem gets. So if we were to solve for y in this case, eventually we would have to divide both sides by 24. And 24 does not go into 4 and 8 a clean number of times. So you're going to work with fractions. Now I feel like I'm all for a challenge. You know what? Me too. But I'm more concerned with you finishing on time. So I wouldn't recommend for you to solve for y in the top equation. But you do you. Now let's look at the second equation. Do we have another nice candidate if we solve for x in the bottom equation? I don't know. If we were to solve for x, eventually we would have to divide both sides by 5. 5 goes into 20 and 5 a clean number of times. So we're not going to have fractions in the expressions. So that would be another good candidate. So in this case, we have two nice candidates, so that's good. I mean, I would settle for one, but if you give me an option, cool, then that's fine. Now, substitution, how does that work? So we're going to look at our notes. Substitution, pick an equation, any equation, and solve for any variable. In this case, we have two nice candidates, so it's like a toss-up. Which one catches your eye? I'm just going to go with the bottom one. So let me speak to myself. I'm going to say, let's look at the second equation and solve for the variable x. So let me summarize that. Look at 2 and solve for x. Fantastic. So let's go ahead and take that second equation and solve for x. Okay, so since we are solving for x, if you're not with the x, you have to go. So to undo the subtraction of 20y, just go ahead and add it. Again, we always do the opposite operation, or fancy talk, inverse operation. When we add 20y to both sides, that will leave us with 5x is equal to whatever your heart desires on the right side. I know that you know that 5 and 20y are not like terms, so you can't combine them. We can only write them side by side as best. You can put 20y then the plus 5, or 5 then the plus 20y. It's really a personal choice. We're not graphing, so I'm not even thinking slope-intercept form, and if we were graphing, slope-intercept form would be y equals, not x equals. So you write the terms however you like. I usually write them from top to bottom, but that makes students nervous, so I'll give the people what they want. So I'll put the variable term and then the constant term. Okay, all right, so we are solving for x. So to isolate the x, to get rid of the times 5, let's go ahead, divide both sides by 5. And I've said it before, I'm really against the long fraction bar, because from experience, when students do the long fraction bar, they'll just cancel out, in this case, the 5s, and they'll forget to divide the other term by 5. But if you divide both sides by 5 by dividing each term explicitly, then you're not going to make that careless mistake, so watch out. Okay, so to finish it off, after we divide both sides by 5, that will leave us with x is equal to 4y plus 1. I'm going to go ahead highlight this. Why? Because that's one of my steps. Okay, pick an equation and solve for a variable. So we picked an equation, namely number 2, and we solve for a variable. Substitution, how does that work? Pick an equation, solve for a variable, and then substitute this expression for the variable into the other equation you didn't use. We already used the second equation, so we're gonna substitute it into the first equation. I usually write in a column, but I'm trying to have all my work displayed on the screen, so I'm gonna do another column. Okay, so pick an equation, solve for a variable, and then substitute your expression into the other equation you didn't use. So I'm gonna say sub into equation 1. Okay, I love speaking to myself. Okay, so let's do this. So the first equation reads 4x plus 24y equals -8. What are we gonna do now? We are gonna substitute the expression of 4y plus 1 wherever we see the variable x. So let's take our time. So that will give us 4 times the expression for x, which is 4y plus 1. But in this case, you know the drill. Let's go ahead, put parentheses around it. Bring down the rest of the product. Plus 24y is equal to -8. Fantastic. All right, let's keep moving forward. Distribute. Product of 4 and 4y will give us 16y. Product of 4 and 1 is 4, and let's bring down the rest of the numbers. Okay, these are not numbers that I can do in my head, so I'm gonna need your help. Let's take our time, combine like terms. When we combine the variable terms, 16y plus 24y is 30, 40. Sorry, that's how I count. That will give us 40y. There's only one constant term on the left. Okay, let's take our time and do this. To finish it off, to isolate the constant term, after we subtract 4 from both sides, that will give us 40y is equal to -12. All right. I'm trying to see something. Okay, cool. I don't think I made an arithmetic mistake, because I don't want to start this video again. Okay, so to finish it off, to solve for y, to get rid of the times 40, let's go ahead, divide both sides by 40. And students typically write their answer in decimal form, so let's give the people what they want. I'm not gonna do it off the top of my head. Okay, for our course, oh sorry, wrong class. For our course, we don't need this these fancy calculators. We don't need a graphing calculators. You can use a regular scientific calculator. That's the one that we use for our course, but it doesn't display as nicely on here. Actually it does, but we'll just stick to this one. Okay, so let's punch it in. 12 over 40, yes, it's -12. I'll just remember to put the negative side, and that gives us a clean decimal of 0.3. So if we were to use decimal of 0.3, don't forget to bring down the negative. So you can write down y equals -0.3, but I'm gonna go ahead, keep it as a fraction, because oftentimes I forget to bring my calculator to class. Oh, I know, I'm a bad teacher. All right, so let's do this. So if we keep it in fraction form, that will give us y equals -1240 is whatever that reduces to. I can't reduce in my head, so cross cancel or whatever. So top and bottom have a common factor of many. I'll choose 4 because that's the first thing that came to my mind. If we reduce by 4, that will give us -3 over 10 or -3/10. So if you were going to write it in decimal form, there's no need to reduce it first, okay? Just punch it into the calculator. Okay. All right, so with that being said, substitution, how does that work? So from the top, substitution, pick an equation, solve for a variable, and then 2, substitute that expression into the other equation you didn't use, and then let the magic speak for itself. Cool. So we want to know what the solution of the system is. So it should be an ordered pair solution. So we want to know what the value of x is, and we want to know what the value of y is. We know what the value of y is, so now let's go ahead, take our time, and find the value of x. So in this case, we want to know the value of the other variable, so we want to find x. Okay, so how are we going to do that? So we're going to substitute a -3/10 for y into any equation of our liking. You can look at the original system, but check it out. The one neat thing about substitution is that you will always have an equation that's solved for that second variable that you need. So if you love yourself, plug it into this one. Okay, so we're gonna have what do we have? X equals 4y plus 1, and then I'm just gonna put what I'm gonna plug in. Do we have to keep the fraction? No, I mean, you can leave it in decimal form. I should have left it in decimal form, but I'm an overachiever. Okay, so that will give us x equals 4 times y, which in this case we're substituting -3/10. I so regret not keeping the decimal, but it's okay, I'm sticking to my gun. Plus 1. So that will give us x equals, do what you gotta do, canceling out the common factors. 4 and 10 have a common factor of 2. 2 goes into 4 2 times, and into 10 I believe 5 times, and that will leave us with -6/5. Product of 2 and -3/5 will leave us with -6/5. Again, I should have just kept the decimal, but it is what it is. Alright, so we add them up. Let's go ahead and write those equivalent fractions. There's only one denominator, so that is the LCD. When we write those equivalent fractions, let's go ahead and write one as a fraction, namely 1/1, and then we'll tell the world that 1 is the same as 5/5. Okay, so I need a bigger table. Okay, so we have x equals -6/5 plus 5/5. Okay, the denominators are now the same. I need to take like a writing class, like how to write neat class. Okay, so when we take our time, sum of -6/5 and 5/5, thanks to our hard work, because the denominators are the same, we have the green light to add the numerators and write the sum over the common denominator. So last time I checked, -6 plus 1 is -6 plus 5 is -1. And then rewrite that sum over the common denominator of 5. Now, if you had entered -3/10 as a decimal, then you would have gotten a decimal equivalent. So I think that's like -2/10. Oh yeah, 0.2 negative. Okay, so what do I want to see, fraction or decimal? To tell the truth, I don't care. Decimals are fine as long as you don't round. If you do the math and if for another problem, as you're doing the fraction to decimal and it turns out that you have to round, no, you have to do nothing. Okay, always exact answer. Please leave it as a fraction. Okay, so we wanted to solve the system. The system, if it has a solution, needs to be an ordered pair solution. So go ahead, tell me what x and y is. Value of x is -1/5, or if you wrote it as a decimal, -0.2. Value of y is -3/10. Both read the same regardless if you have it as a fraction or decimal. Okay, so which one do I want to see? I want to see whichever one makes you happy. Now I'm going to write or, just to let you know that I don't really care which of these two you submit. But as you take your quizzes and tests or your homework, whatever, I want to point out that please be careful with the word or when you're submitting your answer, unless you need the word or because it's part of the solution. Students sometimes write my answer is this or that to let me know that, like, oh, they're both the same thing. But something that I want to point out is this: sometimes you think that they mean the same thing, but they're not. So like if you made a mistake, they're not really the same. Okay, I said too many words. That's my time. Thank you.